Okay, so this will be on velocity, speed, and other rates of change. Okay. First, the author goes back and defines average velocity. Okay, and that is the rate of change of distance. And in this, they're going to use distance. They're going to use the letter S for distance. Okay? With respect to time, over an interval of time. And your average rate of change would be like, we've said it before, like if you were driving from here to Colby and you averaged 70 miles per hour. It's the miles divided by the time. Okay? Then the author is going to talk about the instantaneous velocity. And that's like figuring the instantaneous velocity. Say, okay, you average 70 miles per hour, but I want to know at mile marker, 25, how fast were you going? At mile marker 40, how fast were you going? Okay, so it is the rate of change of S with respect to time at a specific time. At that instant, how fast were you going? Okay, and then the author also talks about acceleration. And I know if you've had physics, you've already talked about all these, right? Velocity and acceleration. But now we're going to do them in terms of derivatives. Okay, acceleration is the rate of change in velocity. Okay, now here's how they all tie together in Calc. Okay, they will give you a formula for distance, and that formula is going to be written as S of t equals something. They will give you some formula for distance. Okay. The first derivative, okay, S prime of t, is the same as velocity. V of t is the same as first derivative of distance. Okay? And then if you take the second derivative of distance, S double prime of t is actually the first derivative of velocity, and it is acceleration. Okay? So if they give you distance, first derivative is velocity, second derivative is acceleration. Okay? Okay, now I'm going to go through a problem. This is a chain problem, okay, that's all tied to the first problem. Okay? Okay, suppose the equation S of t equals a negative 16t squared plus 48t plus 160 represents the position, Suppose the equation s of t equals negative 16t squared plus 48t plus 160 represents the position in feet above the ground of a ball thrown into the air from the top of a cliff. Okay. Okay, so picture-wise, here's our cliff. Okay. Here we are, standing up here on top of the cliff. We throw the ball up into the air. Okay, and then it comes back down. Okay, so something like that. Okay, now they're going to ask more than one question on this same problem. Okay, first question, what is the initial like beginning, what is the initial or beginning height? And they're using S sub 0. What is the initial height, S sub 0, from which the ball is thrown? Okay. When you're doing these, a lot of times you got to figure out what's the 0, but they're actually giving you the 0. Okay. If you write down the beginning equation, S of t equals a negative 16t squared plus 48t plus 160, and they want to know what's S sub 0. Well, if it's S sub 0, then this is 0, this is 0, this is 0. So all of those drop out, right? This one would drop out. This one drops out. So the initial height is 160. So S sub 0 is 160, and we're in feet. Okay, that should be your initial height. Okay, so that's like standing up here. Okay. Okay. Second question. What is the initial velocity? Okay, what is the initial velocity, V sub 0, at which the ball is thrown? Okay. And we set up above, velocity is first derivative. Okay, so if you go back to the S of t is a negative 16t squared plus 48t plus 160. Okay, so S prime, and that's the same as velocity. So take this exponent times the number in front, and then depress that exponent by 1. And then same thing, take this exponent, which would be a 1, times the number in front, and depress the exponent, be just 48. Okay? And they want V sub 0. So V sub 0, this term drops out, and final answer would be 48. And velocities in, like in this case, it's going to be in feet per second. Okay? In feet per second. Okay, so first derivative is velocity. Okay, third question, what is the acceleration? Okay, if you take the velocity equation that we just figured up here. Okay, and then you can take the derivative of that. So velocity was negative 32t plus 48. So acceleration is the first derivative of velocity. So take this exponent times the number in front and then depress that exponent by 1. So it's just going to be negative 32, and t to the 0 is just 1. So, and remember, derivative of a constant is just 0. Okay, and this one would be in feet. Velocity is in feet per second. This one is in feet per second, or feet per second squared. Okay. 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 Then fourth question. What is the maximum height? When you're doing these problems, especially the ones in the book, you really need to stop and figure out, okay, what's equal to 0? Okay, is it the distance equal to 0, the time equal to 0, what's equal to 0? On this one, if you think about the maximum height, okay, you're standing here, you throw the ball up, it comes back down. At the maximum height up here, what's equal to 0? The velocity, right? And that's the slope of the tangent line. Okay, so take your velocity, the v of t, okay, equals a negative 32t plus 48, and it's the velocity that's equal to 0. That whole thing, not the time, the whole thing is equal to 0. And then you solve for t. Okay, and if we could add 32t, or we could subtract 48, either way. Divide by 32. Okay, and you'll get t is 1.5 seconds or 3.5 seconds. Now that's not what they asked for. What they asked for was the height. Now you got to go back. Which formula was the height formula? The height formula goes all the way back up here. That was the very first one, the distance. Okay, so you got to go back to that formula. S of t equals a negative 16t squared plus 48t plus 160. Okay, and then sub in the 3/2 or 1.5. And when you do that, just plug that in, you'd end up with 196 feet. Okay, and you should also be able to check those on your calculator. Okay, so on maximum height, you got to figure out what's equal to 0. It's this slope of the tangent line. So that means first derivative is equal to 0. Find the time, and then sub the time back into the distance. So finally, you get 196 feet. Okay, last question on this problem. When and with what velocity will it hit the ground? Okay, now you got to come back up here and say, okay, this is going up, down. When it hits the ground down here, what's equal to 0? Huh? Height. The height's equal to 0. Okay? So, go back up. The formula for height is the same as distance. So take your original. When it hits the ground, a lot of people think the velocity is 0. No, if I threw something out the window, it's not going to hit with 0 velocity. It's going to smash down there. So it's going to end up with more than 0 velocity. The distance is 0. Okay? So set that equal to 0. Now you've got a quadratic equation. Okay? What's in common in all these? What else? 16, right? Factor a 16 out. And most of you are used to factoring with a positive t squared, so I would factor out a negative 16. So you'd have t squared minus 3t, right, and then minus 10. And if we divide by negative 16 on both sides, we divide that, we're down to t squared minus 3t minus 10 equals 0. Factorable. Remember, this tells you the signs are different. They multiply together to give you 10. If that's a minus sign, they differ by 3. And this is the sign of the larger one. So 5 and 2, right? So t plus 2 equals 0. T minus 5 equals 0. This one, you're going to have to reject. It can't hit the ground before it was thrown. So reject that one. And then t equals 5 seconds. Okay, so now we have the wind. Okay, it's going to hit the ground in 5 seconds, and with what velocity? So now you got to go back to the velocity. V of t equals. Okay, and go back and figure V of t was a negative 32t plus 48. So we need V of 5. A negative 32 times 5 plus 48. Okay, and we end up with, if you simplify this, a negative 112, negative 112 feet per second. Now, this sign just indicates that it's going down, okay? But it's hitting with a velocity of 112 feet per second, okay? That negative sign, a lot of people think they've got the wrong answer if they got a negative. No, that just indicates the direction. Okay, that's a little bit on the velocity's first derivative of distance. Acceleration is second derivative of distance, first derivative of velocity. Okay, now draw a little separator. The author goes through in this you can do velocity and acceleration. What we basically just did was in function mode. Now the author starts showing you some things in parametric mode. We're going to first simulate linear animation, and keyword linear, so they're going to be lines, and we're going to use parametric mode. Okay. First, if I ask you to graph in parametric mode, and they're going to do first vertical, okay, linear animation. Any vertical line, what's the equation for any vertical line? X equals a number, right? So as long as we have x equals a number, okay, so on this one, if they have, and remember these always occur in pairs, if I want to show vertical at x equals 2, okay, and then in y sub 1t, I want you to graph 16t squared. Okay, so you need to go into parametric mode on your calculator. And I'm going to give you a window too. Okay, on the window, when you're choosing your window, if you're saying your x value is 2, then make your window so 2 is going to be in there. So my window, I'm going to choose like negative 1 to 4 and scale 1. For my y, I'm going to do negative 150 to 150, and I'm going to scale 10. And the t, let's say we're going to do the animation for like 3 seconds. So let's go 0 to 3, and let's go 0.1 for t. Okay, so change your window first. Your t is going to go 0 to 3, 0.1 for your step. Your x min negative 1, x max 4, your x scale 1, y min, let's go negative 150, y max 150, and scale, let's go 10. Okay, now let's go back and put the equations in. X sub 1t, let's go 2. Y sub 1t, 16t squared. Okay, and then graph it. Okay, and it goes pretty fast. Remember, if you want to slow something down, if you need to see it graph, you can always slow down your t step to like 0.01. It'll go pretty slow. Okay. One thing I want you to label on this one is this one actually showed. This showed at x equals 2. It showed motion going up. Okay, vertical motion going up. Okay. If I wanted to go down, okay, what do I have to change in my equation so it goes down? Say it. Try it. Try it on your calculators. What do you have to do to get it to go from let's go from 0 down. What do you have to change? Yes, insert a negative in front of the 16. So do an insert and put a negative here. Okay, and then it should go down. Okay, so if I do x sub 1t is still 2 and y sub 1t is negative 16t squared, okay, then that's going to show the motion going down. Okay, so that's just simulating some linear motion. Okay, now let's go horizontal. Okay, and if I want to go horizontal, y equals a number is the horizontal. So if I change it to x sub 1t is 16t squared, and y sub 1t is 2. I'm still going to leave my t is still 0 to 3.1. Now I need to change my x. My x, I'm just going to go from negative 10 to 150 and scale 10, and my y, I'm going to go from negative 1 to 4, scale 1. Same thing here. If you're going horizontal motion and I'm going to graph it at y equals 2, then you got to make sure 2's in between your y min and y max. Okay, so let's change our equations to 16t squared and 2. Then you got to change your window. 0 to 3.1 still okay. Change your x min to negative 10, and my x max is 150. X scale 10. My y min I want negative 1 to 4, scale 1. Now this should show horizontal motion. Okay. And this one is showing horizontal motion at y equals 2, going this way. Okay. Okay, now go to page 200 in your books for a minute. Do you remember the Algebra 1 problems, motion problems in Algebra 1? Train A leaves the station, train B leaves the station. Who gets there first? Okay, now you're actually going to be able to see it. Okay. 200, page 200 in your book. Okay, look at exploration number 1. And we're going to actually look at problem 2 on that. Okay, go down to the middle of the page. It says train A leaves city A at 10 a.m. heading towards city B, 300 miles to the east. Okay, so label train A, okay, and it's heading towards train B on the east. Okay, it leaves at, let's put this one down at the bottom here. Put it, train A, it leaves at 10 a.m. Okay, heading towards city B, 300 miles to the east. So we know this is 300 miles. At 45 miles per hour. We know its speed, it's going 45 miles per hour. Okay, at 11 a.m. Okay, this one is at 11 a.m. Okay, train 2, this would be train 2, and this is train 1 here. Okay, and train 2 leaves city A for city B at 55 miles per hour. So it's traveling faster. Which train will complete the trip first? Okay. You got to go back and use distance equals rate times time. Okay. If you said for the first one, okay, it's going 45 miles per hour for how much time? We don't know. So 45t, right? For y sub 1t, I chose to go horizontally, okay? So, and my first one is this one, and I'm going to graph it at y equals 1. Okay, that's this bottom train. Okay, in x sub 2t and y sub 2t. Okay, this one was 55 miles per hour. I'm just using distance equals rate times time. But this one left at 11 o'clock. So it was out there 1 hour less, right? So 1 hour less than the other one. Okay. And I'm going to put it at the horizontal line. I'm going to put it 1 above. Okay. Okay, now if you said 300 miles at 45 miles per hour, okay, how many hours? Approximate. Yeah, so for time, let's go 0 to 7 hours. And I'm going to go 0.05. I want to slow it down a little bit. X, I want to see the mark, so, and I want it to end at 300. And I'm going to go scale 50. And then for Y, I just need to make sure these are inside my window. So I'm going to go -1 to 3, scale 1. Okay, now, don't run this yet. Okay, but let's put it in. Clear out the equations. In x sub 1t, let's put in 45t. You still use the xt theta n key. Y sub 1t is 1. X sub 2t is 55 times the quantity t minus 1 because it was out there 1 hour less. Okay, and then y sub 2, 2. Okay, and then we need to change the window. Okay, let's go from 0 to 7 hours, and let's go 0.05. For the x, we're going -1, and it was 300 miles away. And I'm going to go scale 50. For the y, -1 to 3, scale 1. Okay, now, there's one other thing on this. If we graph them separately, we're not going to know who wins. Okay, so we need to graph them together. So mode, okay, instead of sequential, we need them to go simultaneous mode. So on your mode, you might want to star that. You want them to graph at the same time so you can tell what's happening in the problem. Okay? Okay. Then you can look the way we've got this set up. You should be able to run this and then see who's going to win. Okay? Just hit the graph. You can watch up here or watch yours. Boom. Which one won? The top one. The one that left an hour later won, but it was going 10 miles an hour faster. But wouldn't that have been great if you were going through Algebra 1 when you can actually see the problem? And remember, if you want to see it again, you got to type over something. Okay? Yep. And it catches up about there, and then the top one wins. Okay? The one that left at 11 o'clock won. Okay? You can, like I said, if you need to slow it down, if we wanted to go even slower, we could change that T step. Can you go even slower? Like 0.01? Yeah. And you will have to on some of these, as you're doing the homework, it's asking you whether this is going left, right, total distance, and you really have to slow it down to look at it. So if you have to change your T step, that will slow it down. Okay? Okay. Yeah, that's as much as I'm going to go through on the linear animation. Okay, and I'll give you time to work on the problems. Okay.